Welcome to VMware ESXi Hypervisor training from ESX Lab. In this chapter, we're going to see how to install, configure, and also administer VMware's ESXi 5.5 Hypervisor. In this chapter, we're going to see a standalone install of ESXi onto a PC server. We're going to start the chapter with a brief overview of the entire installation process. Then what we'll do is we'll take a look at the installation of ESXi onto our PC server. We'll see the initial install steps, and we'll follow that with a discussion of the post-install steps. And the post-install steps include things like configuring networking for your PC server's management port. This involves assigning an IP address, NetMask gateway, and so on to the PC server so that we can later manage it with vSphere client. It also includes setting up time services, security services, and so on. As we go through the chapter, we'll discuss best practices as we come to them. Every project should have a project plan, and our project is no exception. So what we should do is we should discuss now what it is we expect to have done by the end of this chapter. So by the end of the chapter, our goal is to have ESXi installed on local captive storage on our PC server. Now, what does that actually mean? It means that by the end of this chapter, we will have installed ESXi onto our standalone PC server. Installing ESXi involves partitioning local storage on the PC server for use by the ESXi operating system and for VM use. ESXi uses 4 or 5 partitions for the operating system itself, and the remainder of the disk is partitioned and formatted using VMware's cluster file system called VMFS, and VMs that we create in the future will be made on that VMFS partition. And we're going to see how to set up networking so that we can later on point vSphere client at our ESXi host and manage the host using vSphere client. Let's take a look at a block diagram of our ESXi host. First, the foundation. The foundation of our ESXi host is all the hardware that makes up your physical server. So this would be the processors you've installed into the server, the memory you've installed into the server, the network cards you've installed, and the local storage resources available to your PC server. Now, ESXi runs on industry standard Intel or AMD powered PC servers. So what this means is I go out to my favorite server vendor, whoever that happens to be, could be HP or Dell or Lenovo or Supermicro or any other server vendor. I buy the server configured with the hardware of my choice. Then, once I've installed ESXi on the PC server, I run the ESXi operating system kernel, and the ESXi operating system kernel is called the VM kernel. The VM kernel contains major subsystems to control all the resources of the PC server. So for example, there's a subsystem that controls the processor resources. This is the VM kernel's task scheduler, and what it does is it organizes the physical processors, sockets, and cores into schedulable CPU resources that can be used to run VMs. There's a virtual memory management subsystem for the VM kernel, and what it does is it organizes all the physical memory and presents memory to VMs as virtual memory. There's a network subsystem, and the network subsystem allows me to create virtual NICs and virtual switches on the virtual side of my system and uplink those through physical network adapters to physical LAN segments. The network subsystem supports VLANs, it supports NIC teams, and so on. We'll talk about that in later chapters. And then finally, there's a local storage subsystem, and this allows me to take advantage of local physical storage resources and SAN-based storage resources and use those resources to meet the storage needs of my VMs. Finally, there's the VMs themselves. ESXi exists to run virtual machines. ESXi is not like Windows or Linux. It's not a general purpose operating system. Its job is not to offer file shares or run databases or applications. ESXi's job is simply to create and run virtual machines. If I need applications or if I want services for my network users, then what I would do is I would deploy virtual machines and I would actually provision, configure, and publish applications or services through virtual machines rather than the ESXi host itself. What we want to do now is take a look at scaling up our PC server. Now, most of the time when we think about scaling up our PC server, what we think about is making sure we have enough CPU and memory in our physical PC server to run the tasks and services that we intend to host on that server. That's a valid concern, but in our case, it's going to take a slightly different perspective. Our PC server in this case is not going to run tasks and services, it's going to run virtual machines. So I need to have enough CPU, physical sockets and cores, to run all the VMs I intend to host on this physical machine and run them comfortably without CPU contention. I also need to have enough RAM to meet the memory needs of all of my VMs without any memory contention. Now, what we want to focus on in this slide is actually storage and network bandwidth. So let me explain. Ultimately, if you're going to scale up your VMware environment, you're going to connect to a shared storage appliance. This might be a fiber SAN or an iSCSI SAN. The shared storage appliance is going to allow me to consolidate all of my storage capacity. It'll allow me to do central management of all my storage. It'll allow me to scale up the performance of my storage, and it will also allow me to connect to storage through redundant storage controllers. So redundant storage controllers means I have two or more controllers that I can use to get to the storage appliance. There's reasons why I want redundant storage controllers. The first one is bandwidth. If I can send IOs through either storage controller, then I have the amount of bandwidth available to me is the total of all the bandwidth available to each controller. So I get very high throughput. The other advantage is if something goes wrong with a storage controller, ESXi will detect it and it will send IOs only through the healthy storage controllers to the SAN. So you could have a storage controller failure and your IOs would still flow to the SAN, your VMs would continue to run. Without redundant storage controllers, if the only controller I have goes offline, then I can no longer complete VM storage IOs against the storage appliance and all my VMs would blue screen and die. Now, just like redundancy is important for bandwidth and availability and storage, it's also important for bandwidth and availability for networking. So in this particular case, I might have multiple management LANs, or multiple LANs. One I use for management, maybe one I use for production, maybe one I use for storage, file shares, backup, and the like. So I have multiple networks. I can physically or virtually isolate these networks. So I can have multiple physical LAN segments, or I can have multiple VLAN segments. And the nice thing about multiple segments is isolation gives me better performance because my traffic for management isn't competing with IP storage and vice versa. And it gives me better security because people who are connected to the management LAN can't sniff production traffic or can't sniff IP storage traffic and so on. So that's very useful. Okay, it's really useful. Now what I want to do is I want to organize my NICs into NIC teams. So in this case, the reason I want to use a NIC team is so that network traffic gets the added bandwidth of a team and it gets the redundancy of a team. So bandwidth would mean that if all my NICs were healthy, my network traffic could flow through any NIC in a team. And redundancy means if any one NIC degrades, so I have a cable pull, a NIC fails, a switch port fails, then the ESXi host is smart enough to detect it and forward network traffic only through the failed, or away from the failed NICs and only through the healthy NICs in the team. Now, I can have multiple NIC teams, so I would organize all of my networking through redundant NIC teams. And in this way, my ESXi host could continue to talk to its network peers even if I had a single NIC failure on one of my teams. Let's talk for a minute about the kind of hardware that I can actually provision for my ESXi host. We'll start with CPUs. First of all, ESXi is designed for enterprise-class virtualization, so it runs on the largest, most powerful PC servers money can buy. VMware has tested their ESXi software to run on hosts with up to 320 PCPUs. PCPU means a physical processor core. So imagine for a second a physical PC server that's so powerful it has 320 separate physical CPU cores. VMware can handle it. Now, if you've got Intel-powered PC servers, that means PC servers with Intel CPUs in them, then the Intel CPUs must be Core 2 Xeons or newer. This would be 64-bit Xeon CPUs that were manufactured about 2008 or newer. Now, Intel manufactures CPUs with as few as 2 physical cores or as many as 15, and actually they've just released an 18-core monster. So this is 2 cores per physical processor or up to 15 to 18 physical cores per processor. Intel also has hyperthreading, and hyperthreading is a neat trick that makes one physical core look like 2 virtual cores. Sadly, it's not as powerful as 2 physical cores, but it's still a nice trick to have, and if you're an Intel customer, you usually get this for free. Now, if you like advanced micro devices CPUs, VMware supports their Opteron class server CPUs, and Opterons are available with as few as 1 core per physical processor or as many as 16 cores per physical processor. Now, both Intel and AMD have moved to a modern architecture called Non-Uniform Memory Architecture, or NUMA. Now, NUMA says, rather than having a common pool of memory that CPUs compete against for access to the memory, what NUMA does is it says each CPU should have its own local pool of memory. So the neat thing about this is NUMA-aware CPUs can access local memory at full speed, but they can also reach out and access RAM that other CPUs own, but there's a speed penalty to be done for that, or to be paid for that. VMware can support up to 16 NUMA nodes. So that means up to 16 nodes with 1 or more CPUs with local memory. This allows for very efficient, very linear scalability. Now, from a memory point of view, my ESXi host needs at least 4 gigabytes of RAM. Without 4 gigabytes of RAM, ESXi 5.5 simply will refuse to boot. Now, on the very high end of the spectrum, ESXi will use a maximum of 4 terabytes of RAM. 4,000 billion bytes of memory. Now, unless you've got very deep pockets, you'll never get close to that. Now, here's what ESXi does. ESXi examines all available RAM and then reserves 5% of RAM for use by the VM kernel. The VM kernel, again, is the core of the ESXi operating system that owns the hardware and who's responsible for running virtual machines. So 5% is used by the VM kernel. All remaining RAM is available for VM use. So that's CPU and memory. What about networking? Well, it depends on the make and model of NICs that you're using, but in general, you can stuff up to 32 1 gigabit NICs into an ESXi host. So this would be, actually physically, it would be 8 4 gig or quad NICs. You can stuff up to 8 10 gig NICs into your host, and you could stuff up to 8 40 gigabit NICs in your host. Now, 40 gigabit is essentially an InfiniBand controller, so Mellanox makes ConnectX 3 class InfiniBand controllers that can be operated as a NIC to get ultra high speed networking through an InfiniBand network. Now, as far as storage goes, my ESXi host can be configured with local SCSI storage. That's an old standard that's been superseded by SAS or serial attached SCSI. I can have cheaper SATA drives in my ESXi host, or I can have SAS or SATA solid state drives in my host. I can connect to storage appliances through InfiniBand networks, through Ethernet networks to iSCSI SANs, or to fiber networks to fiber SANs. Okay? And I can also reach out through Ethernet networks to NFS shares, network file system shares, that are perhaps published somewhere on my network. And if I have those available to me, I can use them for my ESXi host storage needs. Now, sadly, there's no ability for ESXi to connect natively to either SMB or CIFS, Common Internet File System shares. In other words, there's no native support for direct connections to Windows shares, but we'll see that VMs are certainly more than able to do just that. There are 2 different ways you can install ESXi. ESXi can be either embedded right onto the server, or it can be installed on local storage. So let me explain the difference. First, let's talk about ESXi Embedded. ESXi Embedded is a version of ESXi that you might often find baked right into flash memory on the server's motherboard. So Dell is a very big fan of doing this. Dell will sell certain R-series servers with ESXi baked right into flash memory on the motherboard, and it becomes a bootable device that you can simply select in the host BIOS. Now, even if it isn't baked right onto the motherboard, you can typically install ESXi onto an SD card, and most modern PC servers have SD card slots on the motherboard. You would install ESXi onto the SD card, put the SD card in the SD card slot, and then go into the ESXi host BIOS and tell the host to boot off the SD card. So what happens is, if I have ESXi either baked into flash or on an SD card, the host would simply boot ESXi after going through its power on self-test or post. Now, the ESXi operating system might reside on flash memory. Where does it get its configuration from? And the answer is the configuration can also be on local storage, or it can be retrieved from the network. Now, the other option is that I install ESXi onto local storage the same way I would install Windows or Linux onto local storage if I were running that instead. So I could install ESXi onto local disks or SSDs. They can be configured into either a redundant array of inexpensive disk or a RAID array, or a JBOD configuration. JBOD, literally, honest to God, means just a bunch of disk, and it means a non-redundant disk configuration where I install ESXi onto a physical disk, and then I boot and run ESXi off that physical disk. Now, when I say disk, I'm talking very broadly. It could be a typical spinning disk of some size, or it could be a solid-state device that is essentially used as if it were a regular hard disk. Now, I can also install ESXi onto a USB flash drive. So VMware has procedures that you can find if you go to their knowledge base, where you can take install media, you can actually bake it onto a USB flash drive, connect the flash drive to the ESXi host, and then go into the host and tell the BIOS boot off this flash drive. Now, the neat thing about doing this is I don't need to buy a RAID controller for my host. So I don't need to buy a SCSI or a SAS RAID controller. I don't need to buy hard drives. Literally what I do is I install ESXi onto an SD card or onto a USB thumb drive, plug it into the host, update the configuration in the host BIOS, and boot and run. Now, there's some advantages to this. The first one is that SD cards or USB thumb drives are very easy to duplicate. So I can make backup copies of the thumb drive or SD card, and if I ever have a flash memory failure, I just switch the device, boot it up, and go. Secondly, modern PC servers typically have one or more USB ports inside the PC server. So I can plug the USB thumb drive into the port on the inside of the PC server, so I don't have to worry about somebody knocking a USB key out of the external port on the PC server, or worse, maybe deciding that they want to walk off with it. If they did that, that would crash my PC server and all my VMs running on the PC server. So I can actually have the flash device, either USB or SD card, inside the PC server on a USB port or an SD card slot and just boot from that.